Okay, so you can see here how much of this I've done by scrolling back through it, and I've been saving these as I go along, which is, again, is very important. And I've made a few mistakes here. You can see where for a while there, if you watch this area, I decided to include it and then I didn't include it, and I think in the end I need to go back and exclude. Let me see here. I guess that's the optic tract coming up there. I don't know, it's hard to tell. Oh, it's the optic nerve, that's what it is. Yeah, it's the optic nerve. So I guess I should be consistent. So I'll go back and move these back up. All right, so I just thought it would be interesting for you to see me do some of these. I'm using the left and right arrow keys to make sure I'm on the next slide. D will bring up the pencil tool, right? So that's D. And I don't know that it matters, but I try to always start drawing in the same place. Especially if you're using a Cintiq, it matters a little bit because your hand obscures part of your view. There are some advantages to using just a standard Wacom tablet in that your hand isn't in the way. And with a Cintiq, your hand is at times covering what you need to see. So you get a sense that by watching this, and I'm going very quickly, and I do have the Cintiq, which speeds it up a little bit, that to do this on 170 slices, and 170 is not that many. Some of the, in some of these cases there are 500 slices in a scan. It takes quite a while. So I wish there was a faster way to do it, and maybe one day there will be, or maybe there is now and I just don't know about it. But this is, again, is the only way that I found that it reliably makes a good brain model. The quick and dirty way, where you use the scissor tool and cut away in the viewport in the 3D reconstruction, is fine, except that you can't get in here, and places that are inside concavities, like around the hypophysis and the optic nerves and things, like down in here, you can't really do that any other way but this. And then again, once you've done this and you create a QTVR at the end, you'll have that QTVR forever to use in other projects. And if you don't delete this data set, or you maintain the data set and save a copy of the ROIs, I would expect them to be something that you can use in the future, in future editions of Osirix. So. And again, these are tools that I can't imagine a radiologist ever taking the time to do this. And I'm actually surprised they have the tools in here for doing as robust ROI selection as they do, creation and selection. But in the future, it will probably be even better, and there might be better tools. I would love to see a magic wand or a color range type of tool. Something that had a threshold, and maybe that's in here already, but I haven't found it. So, but I'll keep experimenting with it, and if I find one, I'll make a movie of it, how to do it. So I realize this is about as exciting as watching grass grow, but I think it gives you an idea of where the tolerance is, and I think it's also valuable to compare my drawing here to the final model. That's why I'm going to go through and you'll be able to see the final model that I'm making, to see where these little inconsistencies from slice to slice, how they manifest in the final model. So, all right, I think that's it, and I think the next movie I make will be when I set black as the outside color to all these slices. And this is a good time to go through and save my ROIs. Save all ROIs, give it a new name, and then it's saved. All right? And I'll talk to you in the next recording.